Okay, so we should be live now. Great. I see my audio working in camera view. Great. I don't think this worked last time because I was being silly and I did not enable it. Great, cool. Um, Hello everybody. It is now May 2nd, 9:12 a.m. Doing this a little bit later than I normally do, but that's okay. I have myself a cup of coffee at my co-working space. And today we're going to be exploring the wonderful world of Cyan, which is a React testing library that I that I invented like 3 weeks ago. We've been using it pretty successfully within, at the moment, two projects. One with which is HSDS React, and two within the main application as well. And it's been going great. So I'm gonna show you the library, some of the features, some of the little internals, maybe to kind of get you thinking about certain things or make you give up on JavaScript in general because this stuff is like a little bit hairy. And not in the, oh my God, this is kind of spaghetti code kind of way, as in recursion and math kind of like, oh man, this is a lot to process kind of way. So let's jump into it. Now you can see my VS Code editor, which is great. Um, there has been a lot of development within Cyan, which has transformed it from its kind of original-ish kind of implementation, which is great. It's great to see a library or a project kind of evolve based on the needs of the users, which at the moment are myself and Nicholas. And Ryan has also done some Cyan testing as well. So we can see we're in version 0.8 now. Uh, for a while, it was lingering around 2 and 3, and there was a big change around version 2. This introduced the idea of using fake promises. So Cyan it does kind of two things. One is that it enables you to test React components easier. So if I run the Cyan test runner, which is Jest, at the moment Cyan's only compatible with Jest. Jest's API is very deeply ingrained within Cyan. Um, oh, hang on, I messed up some things. I need to remove this. Just because I'm working on some updates and how embarrassing. Let's get that working. Hopefully this works. And this is one of the things I'm going to talk about. Request animation frame mocking within JS DOM. Anyway, so we have our tests. It's running. Cyan is 100% test covered, which is great. And the really interesting thing is writing tests for your test library for test coverage purposes. I don't know. It's a like a interesting little fun thing to do. Um, So if I check out my tests, if I check out my examples, I have a drop down here, which comes directly from HSDS React. I'm not doing anything fancy with it. I'm just rendering the drop down and giving it some properties. And you can see this is all you really have to do. You render the drop down and you can check to see if it exists or not. So right off the bat, this is already incredibly fantastic because this dropdown uses a lot of different mechanisms, a lot of different components, a lot of different timers in order to render itself, especially in the open state. Can open a dropdown. Yeah, so now I'm clicking the dropdown trigger in order to open it, and I can assert that the menu and the items exist. Um, a TLDR is that the dropdown uses a combination of portal and animation, which have their own, excuse me, which have their own timers in order to make sure it renders the menu correctly at the root body level of the document. Already, this goes beyond what you would think about from a traditional React kind of component standpoint, just because a lot of DOM stuff is involved. And also, lots of math is involved in order to calculate and position the menu in a certain place and so on. Um, and within HSDS React, before the creation of Cyan, in order for me to test all those individual pieces, I had to do a lot of mocking, just to get the tests running and the components rendering. And I wasn't able to really test the entire thing as a whole, just because mocking was too difficult, whether it's mocking the portal, component, the portal mechanism, the DOM math calculation stuff, whatever it was. But here, I don't need to mock anything. I just render the component, it renders, I click it, it opens, it's fine. Um, and yeah, this is absolutely fantastic for me. So one really cool thing about Cyan is, excuse me, I gotta drink some coffee. Ah, there we go. Hopefully that's better. So one really cool thing about Cyan, and Nicholas really liked this feature as well, is that it has first-class support for debugging. At least that's what I'm trying to do. Because when you're writing tests with ingest, you don't have the luxury of being able to see what your components render to, really. Because when you're doing tests in something like Cypress or just developing in the browser, you're able to see how your components render. You're able to interact with it. You're able to inspect element and click to see how the HTML looks like, what the CSS classes are, what those computed CSS styles are. But within JS within Jest, all that is basically invisible to you. And all you really get is the implementation details, that is, say, line 56. Which is fine, but then it feels a little better to be able to see the work that you're like the component or however it's rendering as you're writing your tests. So there is a function within Cypress, Cyan, eh, called debug. And oh, by the way, Cyan is fully typed, at least for the main important APIs. So if you're using VS Code, you get IntelliSense built in for all the methods, and you can see that there are params and examples and stuff like that. It's pretty cool. So if I do sci debug for this particular test, what sci-debug does is that it takes your rendered component or anything that's been injected into the document body and presents that, stringifies that, and presents that very nicely as a console log within your test runner. Um, so yeah, this is the entire dropdown, and the printout of this is slightly different compared to what you would get with a enzyme debug. And the main difference is this looks prettier. So there's I modified the indentation of the HTML so that it prioritizes the indentation of attributes, very similar to how you would traditionally write React code. This, at least for me, enables me to read the HTML markup a lot easier, just because in the world of React and in the world of component libraries, a lot of attributes get added in, especially if you need accessibility support for like ARIA roles or anything like that. There's a lot that gets injected. So being able to see it in this kind of clean way is really nice. Um, the other feature I added in yesterday to debug is you're able to see a certain slice of the rendered HTML. So for example, let's say I only want to, for reasons, pay attention to this particular selector. So I can debug this particular selector like that. It'll do a query selector for that element. And now I'm seeing just that slice for my debugging, which is kind of cool. So as you're running your test, maybe you have a gigantic dropdown or mobile or some sort of menu component, and you just, for reasons, want to see the HTML markup for that one singular active menu item. So with this kind of query selector feature built into debug, you can, and it's really nice to be able to do. One tiny caveat to HTML console logging within Jest is this is not a Cyan problem. This was a Jest problem that's been well known and fixed within the latest and greatest iteration of Jest. And that is within Jest 23, Jest is now in 24. Within Jest 23, there was a problem where if you ran Jest with the watch flag on, it runs your tests concurrently, which is great. However, there was something messed up in there that swallows up console logs, um, and there wasn't really a good way to kind of go about testing when you need console logs. And I do console log testing all the time. just because I work a lot with components and markup and all that kind of stuff. Even when I do things in the browser, I personally prefer console logs over debuggers. That's just me. Um, but yeah, so within Jest, if you did a console log anything, there was a chance that it would swallow up and then you don't see it, or you might even just see a portion of it. So those of you who are on Jest 23, one workaround that I found to work 90 something percent of the time is to basically console log the thing that you want logged. For example, let's just say, I don't know, I want to log my Cyan function thing. Log the thing you want logged, but then also before that, give some gigantic object. Like within this just case, you can give it global, and this will be a gigantic object which will force essentially the logs to show. That was a workaround within Jest 23. So what you're seeing right here, you're not seeing that problem because Cyan has been upgraded to Jest 24, which comes from 0, which received Jest 24 in upgrade 320. 321 was a little minor bump I did in order to um, improve the Jest config just for 24 purposes, just to make it a little bit easier to integrate. But yeah, 320 helps go 0, gives you Jest 24, and Cyan is using Jest 24. Jumping a little all over the place at the moment, but I mean, these concepts are really concepts or implementation details or just like general how to use software when or in tooling is pretty important because I mean the console log problem of 23 I've seen that issue happen all over the place and people just suffer through it and they don't know why and that kind of stuff sucks. So anytime you I guess feel a bit of friction when it comes to developer experience, at least for me, I make it a priority to try to make that better. Um, cool. So we've seen Jest, we've seen Cyan being used with Jest in order to render a very complex component from HSDS React out of the box with a very simple API. And the philosophy of Cyan originally was very, very much in the realm of Cypress, in that, well, that's where the name Cyan kind of comes from. It's a play on the word Cypress and has Cypress-inspired APIs for you to write tests within JS DOM. Basically, the Cypress of the JS DOM. Um, but that started to shift a little bit starting 2 days ago when Nicholas was trying to write finer grain unit tests with Cyan, just like you would with Enzyme. So that introduced this idea of making the render method a little bit more feature packed. So previously, what render did when you did side render, let's dive into actually what it does. Um, Actually, not yet. I'll save that in a bit. So render, what it does is that it mounts your component into the virtual DOM that is JS DOM. And that's all it did. It didn't do anything else. Um, but what Nicholas wanted to do, and this is very, I understand this use case, very handy, is he wanted to adjust the properties of the component after it had rendered. So if you're using something like an enzyme, you would do something like const wrapper equals mount component, and then you can do something like wrapper set props, and then you give it some props, and then you go through. So you're able to manipulate the props after the fact, and then you can run assertions on that now updated wrapper. Um, and previously, you could not do this with Cyan, just because render didn't have, well, there's two parts. One is to somehow give the the ability to update properties of an already mounted component. That's one. Two is to re-render that component. And three is to expose set props. to the instance or object that you get back after instantiating render. So you can do this now. This workflow is fully supported within Cyan, which is great. So now you can actually run your assertions against uh, after by setting props after the fact. And the difference between this and enzyme is literally just this, which is cool. Which is cool. So how does that even work? So within Cyan, there's a folder called render, and excuse this kind of mixture of JavaScript and TypeScript at the moment. Cyan was originally written in JavaScript, and I'm slowly converting that over to TypeScript. Um, cool. So render used to return an object with several methods attached to it. Well, it would render the thing into the DOM and then give you in return an object with several methods. And those methods were things like cleanup and some other stuff, nothing to do with manipulating the component or anything like that. Um, so now what it does is that it returns a new render wrapper. This idea of having a class, a wrapper class, and then having instances of that wrapper class with methods built into it was very much inspired by Enzyme, actually. So, uh, we can ignore this part. This little feature came in yesterday evening. Yeah, afternoon, evening-ish. So ignoring that part. So what do we need to do? So render. This is the magic behind Cyan of how it's able to render your component into the DOM. So the first thing we do is we set up the component. What does that do? We basically, this is the very interesting thing about React. Okay, so we basically store your component and the initial props into as an instance variable within this render wrapper. What is this even doing? So here's a really cool thing about, or interesting thing about React. There is a, so if I had some component, I need to pick a theme. Uh, let's do South Park. So if I had a Kenny component, right? And Kenny did, nah, maybe a Randy Randy Marsh. I had a Randy Marsh component, and he had a greeting of "Hi Stan," and all Randy does is that he renders that greeting into a div. Right? This is a very standard, straightforward, South Park inspired stateless functional component within React. So there is a difference between this and this. This is after, with JSX, your component has been instantiated and created with React. The equivalent of that would be React create element, I believe, Randy Marsh. Because JSX is basically shorthand Babel transformation stuff in order to give you something like this. So yeah, there is a very big difference between this and this. This is your raw, uninstantiated React functions, component function slash class. This is after it's been instantiated, and I can show you what it looks like. Um, so let me just isolate some render tests so that not everything is firing. This one, oh, by the way, um, quick tip. So within Jest, if you run it within watch mode, you get this kind of watch experience, which is great. And if you press P, you're able to do finer grained searches to run just an isolated set of tests, which is cool. Um, and this kind of fuzzy file matcher thing that you're seeing right here, this was actually part of Jest back in, say, 20 or something like that. However, the team removed it, but it's now available as a plugin. So with Zero, that plugin has been added in by default just because I really like this fuzzy finder thing. You get a really cool experience and you can press up, down, and all that kind of stuff in order to find your files. It's nice. So yeah, highly recommend that. Um, improves your workflow like crazy. Let's see. Yeah, let us test only this one so I can see the render stuff happening. Yeah, so skipped everything and now we're just running one test so I can show you what this is doing. So when you're doing render this component, setup component, I'm just going to console log this, console log component. Those of you who have done console logging of components in the, what the heck? It's not there. Why? I don't understand. What? Why is this not being called? Sci render thing. Okay, hang on. Console log. So I can log this guy out, I suppose. What? Oh, are my logs being? Oh, that's why. Duh. Okay. So for these tests, I have mocked out uh, console log. That's why it wasn't working. Okay, I'm just gonna restore it just for demonstration purposes. Um, that explains a lot. Oof. I thought I broke something crazy. So now I'm gonna console log component. Nope, not comment. Component. So we can see something happening. This is what your component looks like once you've instantiated it with a React Create component. You get a type of whatever, and then you get the function, and then these are the initial props, or these are the properties that you passed into your component. So what Cyan has to do is that it has to deconstruct this, essentially, in order to get your original React component before it instantiated. That way, it could render your component. It stores it as under this component, and by doing that, it's able to render your component without any properties added in. So for this example, we have title hello as properties you've added into render. I need your raw component without title hello attached to it. That's why you see this thing happening in order to um, get your raw component. And you can do that by basically tapping into component type. This is the function that instantiates your component. Great. So now I have the thing that I'm able to render your component with. And then the initial props are the properties that you passed in here, which you can see from props here. So now that I've deconstructed that and stored them under component and initial props, I can now proceed to render your component. And this is really important because this is the mechanism that allows you to change and set props after the fact. Because I need your raw component with no additional props added in so that when you do set props and manipulate props after it has rendered, I'm able to re-render that component with the new props you provided. Um, Hopefully that makes sense. So great, we've set up our component. Now we're going to mount it. Now what does mount do? We are going to set up. So this runs twice, which is fine with me. Very fast. It's not a big deal. The reason why this runs twice is I will get into that after. But let's just ignore this for now. I promise I'll come back. Set root node. This is really important. Set root node, what does this do? It does a cleanup. And what cleanup does is that it basically unmounts any potential components that might be within the document body. And then it cleans it up by basically doing document body inner HTML equals nothing. It wipes it clean, which is really important to consistently remount and re-render your components into this virtual environment. So we need to set the root node. Create root node, what does that do? Oh boy. So this is a workaround I had to kind of do within JS DOM/React. So React doesn't like it React DOM rather, doesn't like it if you did this. So I have my Randy Marsh component, and if I did React DOM render Randy Marsh into document body directly, it throws a warning or an error. It doesn't like that at all. We can't do that. You have to render your React component into a document, into an element somehow. So people typically do this by doing something like query selector root, which gives you a document element of root that's already been rendered into your page, and then React will render into that. So with Cyan, I need to basically, on every single render, create a brand new root node because uh, the previous thing I did was wipe it clean. So I need to create a new root node every time. So I'm creating an element of this very special selector. The reason why I have it under Cyan root node, which, funny enough, JS DOM can render, which is great. Cyan root node, and you had your Randy Marsh component. Hang on. So what actually renders into JS DOM is this. This is the body. And then you have your Randy Marsh component, which is a div. And I stand. So this is the thing that gets rendered into JS DOM. Yeah, so Cyan root node is it's just something I needed to mount your application or your component into to make React happy and render it into the document body. Um, the tricky thing about this is that if your component happens to have any kind of portaling built in where you mount things at the root body level, like I had, say, div class modal is something, and you have a modal here. Now, in theory, it's outside of Cyan root node, which I have a workaround in order to like do stuff with, but I will get into that. So yeah, that is why we have this create root node going on, and I need to add that to the document body so that your component has something to render into. Um, great, so I set up the root node. I will now wrap your component with some providers from Cyan. And all this does is that it sets up your component with a provider from React Redux and also a router from React Router. And the reason why I do this is so that you get out of the box support for React Router and Redux. So typically, if you were to mount a component without having those providers, React will complain or it'll blow up just because you're not supposed to use connected components or React Router components outside of that world. You need those guys. So typically what people would do in tests is they would have something like you would have to stub in a provider or a router or both by writing it inline, or if you happen to have a test helper method like a mount with provider or something, you basically have that built in, or you'd have that and then you'd have to mount with that particular function instead of the default mount from Enzyme. Um, so with Cyan, I basically took that kind of idea and made it simpler for you and invisible. So you don't see that happening. You can mount your connected component just fine without it blowing up, and it'll be great. Less work for you to write, which is the whole idea. Run all timers. I think I did this just to clear the timer, just as like a fake timer queue, just so that we're getting it ready for your component to be fresh without any kind of influence from the outside, whether it's DOM based, timer based, or anything like that. So now we're going to render. We're going to finally render your component with the initial props that we have. like this so. And all this does is that it renders your component with props. It calls React DOM render into the root node, and that's it. That's all render does. But this is the big change. It returns itself, and what itself is, in case this is a instance of render wrapper, which extends the Cyan class. And the Cyan class is the guy that has all the methods built in. So if I check out this uh, here, so if I did sci render a div, check out this IntelliSense support, kind of nice. So now what render has returned is an instance like itself, which had all the Cyan classes, Cyan methods. So if I did dot, we can see that everything is here. All the events, all the query selector based stuff like find, um, all the assertions like exists, that, which enables you to cache the instance of sci render into wrapper, giving you that enzyme kind of experience. And that's how it works. Uh, Taking care of the render mechanism, making sure that render wrapper extends the Cyan class so that you get all the methods, and returning itself on the render. So jumping back over to here, the mount. Why did I have to call set component? Because now we're calling it twice. One for the initial constructor, and now again for mount. The reason why I did that is because within enzyme, you can do something like this, where you have your wrapper, and then you unmount the wrapper. You maybe write some tests, and then you can remount something. So in order for me to allow you to remount your component or whatever it is you need, um, that mechanism of like setting up the components, setting up the root node, like this mechanism has to be called again. So if you want to, for reasons, keep wrapper around and remount like a different thing, the mount method has to be able to understand how to interpret this very similarly to render, the initial render call, so that your component can mount properly and your test can work just fine. So now it's failing because I told it to unmount, and now all this stuff is missing, which is what I expect, which is good. It's good that that's working. And also this does not work because yeah, I don't know what the heck is going on there. I was just writing garbage code. Yeah, so that is the new render mechanism of Cyan, allowing you to set props after the fact, re-render, unmount, remount, and be able to have all the um, query selectors, event methods, and all that kind of stuff built in to the render instance, like so, giving you a complete enzyme-like experience, but with a Cypress-backed render mechanism, which is the best of both worlds, I guess. And I did write some docs about this. So if you check out the Cyan website, handy dandy marketing website, cyantesting.netlify.com. Right. So if I go here, oh, by the way, this has dark mode support, by the way, which is kind of cool. So these docs are written and compiled with a library called Docusaurus. Very cool name. I love this name. So fun. And also the mascot's this little dinosaur guy. It's cool. So Docusaurus is great. It's one of the best kind of documentation building libraries that I've tested and used, which is why I used it for Cyan. It's not loading now, but built by Facebook, powers the docs of Jest, Redux, and so on. Very popular library. Anyway, so I've written some guides here under testing a simple component, and there is something here called conventions, which I did talk about like an enzyme kind of test flow versus a Cypress-like kind of test flow. Both are valid. Um, both workflows are valid. You use the one that you feel most comfortable with, or the one that suits your current workflow the best. Um, the main difference is with the Cypress-like workflow, you don't cache the render thing as a wrapper and then you do things with that. You basically render your component and then you do some query selectors or whatever the heck after the fact. You don't cache it around. That's the kind of main difference between the two. Under the hood, it works the same for Cyan. It just whichever workflow feels better for you as a developer, you use that one. Yeah. So the other really cool thing about Cyan, and we'll get into this one, and I am gonna call it a day after that for this live stream, is mock promises. Um, Jest has mock timers built into the library. So if you do Jest, use fake timers. And this is really, really nice for you to be able to bypass set timeouts and all that kind of stuff, just so that your component, your function, or whatever will fire instantaneously. Um, and unfortunately, out of the box, Jest doesn't have support for promises with that same kind of functionality and workflow, which is a shame because once you start building more complex stuff, promises is very much a thing, especially if you have to deal with data and APIs and all that kind of stuff. Promises is super a thing. So in the past, what I did to kind of get around it was basically wrap my promise-based functions or components or calls or whatever it is in sort of like a set timeout and give it some sort of arbitrary number, like, I don't know, 100 or something like that, and make my Jest test run asynchronously so that the promise can fire and then I can assert against that promise. But with Cyan, I essentially created and provided a workflow very similar to used fake timers, but for promises. So you can use fake promises from this Sci object. And similar to use fake timers, there is a mechanism built in for you to increment or run the next following promises or running all of them. So this timer mocks thing, there is run all timers, which is here, which runs all pending timers, or running all timers within the queue. And then is run only pending timers. Truth be told, I don't really know the real differences between the two. I've always like been able to use one or the other and it was fine. Um, but for this mock promise thing, there is a difference between run next promise and running all promises. So here's the difference. When you use fake promises, what it does is that it stubs out the global window implementation of promises with a mock one. And this mock one comes from Cyan right here. And it's basically a promise polyfill with full support for resolve, reject, then catch, finally, and all. That ensures that your code runs normally. But it does some interesting things that enables it to fire and run instantaneously. That way, there's no set timeouts. There's no any kind of like asynchronous queuing that you need to do. It just runs, which is perfect for testing. The other thing that it does is that it adds itself to a promise queue, which lives within Cyan and is part of the thing that powers this use fake promise library. That way, if your component happens to have, say, 3 promises that happens during its render mount lifecycle, um, you can, all those promises are added to a queue, and then you can incrementally fire those promises so that maybe if you wanted to, you can have fine-grained control and like what happens when the first promise resolves? What happens when the next one resolves? So you have fine-grained control in terms of incrementing your component, the render cycle and forward, which is great. And if you don't want to do that, you can just do run all promises similar to this run all timers thing within Jest, and all your promises resolve, and then you can do your assertions against that. Um, as a convenience method, if you, for this particular test, just want all your promises to be mocked and run immediately, you can do something like this. Before each test, you can use fake promises, and then you can run promises immediately. And that basically what that means is there's still your promises are still mocked, they're still added to the queue, but the queue just like all of them fire right away. That's it. There's no incrementing. You don't need to do anything. So this is really good for components like, I don't know, within HSDS React, there are components that have promises built in to like an on before open or on before close, that kind of thing, where those are promises that need to be resolved before the actual action happens. So being able to have this kind of run promises immediately at the beginning of my test is great. Because now I can just write my test without having to think about promises being needing to be resolved. I don't need to babysit it. Um, that's one thing I really don't like about programming in general is having to put a lot of work in babysitting something or mocking something or like fiddling with stuff. Because now you're spending all your time fiddling and like babysitting and doing all this kind of like scaffoldy setup work before you can actually do your thing. Whereas you should be spending most of your time doing your thing. Um, so yeah, that was the main driver behind this fake promise thing. And there was a really great suggestion by PL about being able to fake the, I guess, destiny of that promise, whether to force it to resolve or to reject. So right now, uh, the force resolve slash reject mechanisms within Cyan apply to all of them. I can't you don't do it incrementally. I don't have support for that right now. Maybe I'll add it in the future if this is important enough. So what you can do is, and once you fake your promises, you run this method before the render of your component, and any kind of promise that will happen here is forced to resolve. Similar, if you do this, oh, I have a typo in my docs. This should be forced to reject. How embarrassing. Um, yeah, forced to reject. Yeah. So yeah, here same thing, but you're forcing it to reject. And the cool thing about this is that there is middleware built into this so that you can intercept the result or the reason in the case of reject and so provide your own kind of result or reason. So this gives you finer grained control if you wanted to for mocking for reasons. So yeah, this is the promise mock promise feature built into Cyan, and it's working wonderfully. A really good, I guess, testament to this working is I have this set up within the main application to render an entire React application with Axios calls for fetching data, which has been mocked, um, and like lots of promises happening, lots of like Redux things happening, and literally all I have to do is after setting up fake timers and using fake promises is render the application and it renders and it's fine. So the application we have is called greeters. So after it's like literally all I have to do is this. And the application in its entirety, Axio supported promises, timers, all of that stuff is just taken care of for me. I don't need to mock anything. and now I can run my assertions against greeters. So I guess in the enzyme kind of world, no, I'm gonna do this kind of Cypress kind of world. So I can literally just do get by Psi. Get by Psi is a method provided by Cyan. Um, and all that does is it uses the get method from Cyan, but it's looking for this data psi query selector specifically. So it's just a shortcut for data for psi dot get and then data psi equals whatever, whatever. So it's a shortcut for that, which is great. So now I can do this like heading text to be readers, something like that. So now there is a heading that renders somewhere within the DOM, and I'm making sure that the text is greeters because that's what happens when the greeter application loads after it fetches its data. Um, and if I'm not sure what the markup is, guess what? I can just run the debugger while I'm running my test, and now I can see the complete gigantic uh, application markup that is this greeters application. And yeah, so this is Cyan, giving you the Cypress slash enzyme kind of experience within your React slash testing jest testing workflow. Comes with a bunch of conveniences built in. Uh, the big one being the mock promise kind of API. I'm just going to reset stuff here because I'm poking around. Oh, I'll figure that out later. Yeah. Um, yeah, being and enables you to render small things like components or full-on applications. You're able to write unit tests or integration tests very easily. And it's been working great for us within HTTPS React, and it sounds like it's been working great for us within HSApp. So thank you so much for tuning in. Hopefully you found this entertaining, useful. And if you have any kind of feature suggestions, ideas, or even bug reports or anything like that in regards to Cyan, please let me know and we'll take care of that for you. So thank you so much for tuning in and I hope you have a great day. Take it easy. Bye.